Capacitor. Hi everyone, welcome to this video on capacitors. Today we will explore that capacitors are, how they work and why they are important in electrical circuits. What is capacitor? Capacitor is a device that stores electrical energy in an electric field. It consists of two conductive plates separated by an insulating material called dielectric. Capacitor is having the ability to store an electric charge. C denotes the capacitance and stores the charge as C is equal to Q divided by V, where Q is the quantity of charge in coulomb. V is the voltage applied. C is 1 farad when Q is 1 coulomb and V is 1 volt. Farad is too big unit for day-to-day use. Microfarad, that is 10 raised to minus 6, is the unit normally used. When a voltage is applied, the capacitor stores energy by accumulating opposite charges on each plate. This ability to store charge make capacitors useful in many electronic applications. Capacitor losses are the losses due to active power dissipated by the capacitor, that is dielectric losses, generally expressed in watts per kVr. An assembly of capacitor units connected in series or series parallel is called capacitor bank stack. A number of capacitors connected together in such a way as to get required rating at a given voltage is called capacitor bank. The solid and or fluid insulation between capacitors electrode is called dielectric. Dielectric constant permittivity. The ratio between capacitance and dielectric compared with that if the dielectric was air, dielectric constant of air is taken as 1. Dielectric stress, the voltage across the dielectric oblique thickness of dielectric, generally given as volt per micrometer. Discharge device, a device connected across the terminal of the capacitor to reduce the residual voltage to a safe level after the capacitor is switched off. There are several types of capacitor including ceramic, electrolyte and tantalum capacitor. Each type has unique properties suited for different uses. For capacitor 660 volt and above, the voltage should be reduced to 50 kV within 1 minute. For capacitors above 660 volt, the voltage should be reduced to 50 volt within 5 minutes. Capacitance tolerance. The permissible difference between actual and rated capacitance is plus 10% to minus 5%. Tangent of loss angle tan delta. This is a tangent of angle by which capacitor current falls short of 90 degrees leading angle. If tan delta is equal to 0.0006, then loss is equal to 0.6 watts per kVr. Parallel connection. The figure shows the parallel connection of capacitors C1, C2, C3. The total capacitance C is calculated as C1 plus C2 plus C3. Series connection of capacitors. Figure shows the series connection of capacitors C1, C2 and C3. Total capacitance C is equal to 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Therefore, C is equal to C1, C2, C3 divided by C1, C2, C2, C3 and C3, C1. kVr rating of capacitor. Capacitive reactance is equal to Xc is equal to 10 raised to 6 by 25 Fc, where C is the capacitance in microfarad, F is a frequency. Capacitor current is equal to IC is equal to V by XC is equal to V into 2πfc divided by 10 raised to 6, where V is applied voltage. VAR rating of capacitor is equal to IC square into XC. kVAR rating is equal to IC square into XC divided by 1000. For 3-phase kVAR rating, 3 IC square XC into 10 raised to minus 3. Dielectric in capacitor. The following are the various types of dielectrics used in the capacitor over the time and corresponding reduction in losses. Paper oil impregnated to 2.5 watts per kVAR. Paper PCB impregnated 3 to 3.5 kVAR. Plastic film paper PCB impregnated zero point 0.5 to 1. Plastic film paper oil impregnated 0.5 to 1. Metallized film below 0.5. Plastic film opposite below 0.2. Applications. Capacitors are used in power supply systems, signal processing and energy storage. They help smooth out voltage fluctuation and filter signals. Thank you.